Hey Maths Legends. When I was your age, I really struggled with equivalent fractions and mixed fractions, so I thought this would be a good video for everyone. So today we're going to be learning about how to identify and calculate a equivalent fraction, and then we're also looking at mixed fractions, so how do we turn an improper fraction into a mixed fraction. Alright, enjoy the maths video. Bye! All right, legends, let's have a look at this one. So this one's going to talk to you've got a loaf of bread. Okay, it's the same size. Now, got to remember that this loaf of bread here is the same size. All right, and what this person's done is that they're trying to slice it up into even amounts or into fractions. Okay, so for this one, they've got this loaf of bread. Now they've cut it in half. All right, for this load of bread, they've shared that between 2 people. This load of bread, they've shared this between 4 people. Okay, so that's half of loaf. This side over here, they've actually shared this amongst 8 people. So you've got 4 and then 8. And basically what they're saying is that these are all equivalent fractions. So this size of the bread, okay, is the same size as this loaf. These loaves, so 1, these 2, and these 4 are all the same size. So they're equivalent. So we say that those things are equivalent. So if we look down the bottom here, here's some more fractions that are equivalent fractions. So we've got 2/3 over here. You can see there's 1, 2, and 3, and 2 of those are shaded in. Now you can see in the one below it, you've got the same amount that's shaded, but this time you've gone 4/6. So 2/3 the same as 3/6. And we can tell that by looking at our sums like this, by having 2/3, okay, and then we have 4/6. So if I times the 2 by 2, that equals 4. And if I times the 3 by 2, that equals 6. So whatever you do to the top, you must do to the bottom. So when you're trying to find equivalent fractions, whatever you do to the top, you must do to the bottom as well. Okay, so it says here the chocolate bar. Now let's look at this one. You've got 6/9. So 6/9. Okay, so what I'm going to do is I'm going to rub this out. And we're going to write the fraction 6/9 over here. Okay, so 6/9. So to get to that, 2 times 3 is 6, and 3 times 3 equals 9. So that's 6/9. Okay, let's look at the last one now. So we've got the one more is the 8/12. Okay, so if I go over here and I say, well, that's 8/12. So 2 times 4 is 8, and whatever I do to the top, I must do to the bottom. 3 4s are 12, so 8/12. And you can see those are clearly written just here, okay? You can see that that's the same amount, okay? But the fractions are different, okay? And you can see that the smaller the denominator, the larger the fraction. So the smaller the denominator, as the denominator and the numerator get bigger, also as the denominator gets bigger, you can see those fraction sizes become smaller. So 6, they're that big. At 9, they're this big. At 12, they're that big. All right? Hopefully that makes a bit of sense. Let's move on to the next ones. So just like we had before with this one, colour each part of the row showing the fraction. So you've got 1/3 there. So I'm going to look at these ones here. So I'm going to shade these ones, okay? I'm not too neat in the lines there. So now when I look at that number, okay, that is 2, and I count up my denominator, which is 1, 2, 3, 4, 5, 6. So that's 2/6, okay? The next one, when I shade that in, it's going to have to be the same. So it's colour that one in, that one, and that one. So this time, when you look at it, I've actually shaded in 3, and then I count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9 is 3/9, okay? And the final one is 1, 2, 3, 4. So my denominator is 4, and my numerator is 4. My denominator is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 twelfths. Okay, so then down the bottom I can say, and I'll put that there, 4 twelfths, and I can say, well, 1/3 is the same as 2 sixths, and 1/3 is the same as 3 ninths, and finally 1/3 is the same as 4 twelfths. Hopefully you picked that up. 4 twelfths. Okay, so our last task for this equivalent fractions is just here. I'm going to make this a little bit bigger so we can see it. This one here. Okay, so it says write each fraction beside the pair. So so the first one's done for us. So you can see these are exactly the same. That's the same there. So as we look at this, this is the same through here, and that's the same through there, and that's 1/3 and 4 twelfths. So this is the same and this is the same. I can count these 1, 2, 3. So that's 3 quarters. There's 4 in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is the denominator there, and then 13, 14, 15, 16 is the denominator there. Okay, we're going to move over to C now. Look over at C. I can see these are all equivalent fractions, the same amounts shaded in. I can see there's 1, 2, 3, 4, so 2 over 4, and I can see here 1, 2, 3 over 4, 5, 6. Okay, so 3, 6. All right, and obviously I've just enlarged this a little bit here. Let's have a quick look at this now. So I've got 1, 2, 3, and what parts of those are shaded? So I can say, well, I'm going to look at the shaded part. There's 2 of 3 that are shaded, or there are 4 of 6 that are shaded. So they're equivalent fractions, okay? So when we look at those, they're equivalent fractions. Looking at this one over here, I've got 1 shaded of 5, all right? And then over on this side, I've got 2 shaded of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 of 10. So they're equivalent fractions too. All right, I'll quickly do D as well. I can see that there is 1, 2, 3, 4 shaded of 5. And straight away, what I'm going to say is, I think we're just going to try this. 4 times 2 is 8. Whatever I do to the bottom, I must do to the top. 2 times 5 is 10. Let's have a look at that. 1, 2, 3, 4, 5, 6, 7, 8. 8 over 10. So that's my equivalent fractions there. All right, that brings us to the end of your lesson 1 of this video. All right, Maths Legends, let's look at this one. This is converting improper fractions. So if you look at what's happened over here, you've started off this over, when you've got the numerator is larger than the denominator over here, that's what we call an improper fraction. So we've got 5/3, and that's an improper fraction. So if we're looking at a pizza, we've eaten 5 slices of pizza, but each piece has only got 3 slices. We must have eaten multiple whole pizzas, okay? So we need to make sure that when we're looking at improper fractions, you need to convert them to mixed fractions or mixed numerals like they've got over here. So if I was to look at this like it was a pizza, I'm going to draw now a couple of circles. We're going to see how we go with that. So I've got one circle here. I've got another one just here. And then I've got, so what I'm going to do is I'm going to cut that up into thirds. All right, so I'm going to cut this into thirds. So I'm going to then break this up into thirds. So if I go down through here, break this into thirds, and hopefully they're as even as I can. It's not the most even thing I've ever made, I'm not going to lie to you, but it'll do. You can see that I have 2 pizzas there that have got 3 slices in them. Let's go that we're going to eat these, and we're going to put them as green. So what I'm going to do is 5/3. That means I've eaten 5 slices. So that's 1, 2, 3, 4, 5. All right. So what that means is I've eaten 5 slices. And what I'm going to say is I've eaten 1 whole pizza. So if I get my pen now, I've eaten 1 whole pizza. So this pizza's now gone. All right. And I also ate another 2 slices. And because they all started out with 3 slices, the denominator is always third. Okay. So that's how we figure that out. So that's a mixed fraction. So you can see that that's how a mixed fraction looks. All right, now what I'm going to do now, I'm going to look at the next part of this sum. The next part of this sum requires us to look at how do we calculate these? How do we calculate these improper fractions into mixed numerals? So you can see they've got over here, they've done a little sum. They've said 11, so you can see that the 11's on top there. 11 divided by 4 equals, so there are 2 4s in 11. Okay, so 4 plus 4 is 8. And then my remainder is 8, 9, 10, 11. So that gives me 3 remainder. And of course, the denominator never changes, okay? So the denominator, just like our pizzas down the bottom here, they never change from being 3 slices. Let's have a look at that and apply that to how we did our 5/3. So we put our numerator, so our numerator divided by our denominator, which is 3, equals, so there is 1 3 in a 5, and then you have 4 5, which is 2, remainder, and then I use the same denominator again, which is 3. All right, we're going to have a go at that on the next page, but if you need to, you might need to watch this video again. All right, Maths Legends, right at the very end, let's go through this now. The first one's done for us. They've said 9 divided by 2, okay, equals 4 remainder 1. Okay, so 9 divided by 2 is 4, because 2 times 8 is 4, and then I've got 1 remainder. Let's have a look at the next one, okay? So the next one is, and I'm just going to go 16 divided by 5. So 16 divided by 5. Well, 16 divided by 5 equals, sorry, I'm just trying to move my pens away. 16 divided by 5 is 3, remainder 1. All right, let's look at the next one again now, please. We've got 14 divided by 3, okay, equals. So let's have a look at that. We can even put our 3 times tables on the side here. We're doing division, and we go 3, 6, 9, 12, 15, 18, okay. So straight away, I know that I've got to get to 14, so that's 1 over here. All right, so that is 4 remainder and 12, and count it using your fingers, 13, 14. That's 2 remainder, okay, 2 remainder, and you need to make sure that you always put your denominator in, and hopefully you pick that up on the last one. That 5 should go over here, remainder 5, okay, just like that, all right? So this time, when I'm doing my mixed fraction, it actually looks like this. So as I go through, it's going to be 3, 1 over 5. This one is 4 with 2 over 3. Over the top here, it is 4 with 1 over, and then that denominator sits there again, okay? That denominator never ever changes, okay? So that denominator never changes. So let's have a look at the next one together. So you've got 11 divided by 2 equals, so 11 divided by 2 is 5, and then it's remainder 1, and then you have 5, 1, and then use the denominator again, which is a 2. All right. What I might get you guys to do, pause the video here, and then we'll I'll fill them out, and then I will do the last one together. All right. So hopefully you got those right through those. So check yours now. What I've also got here too, we'll do the last one together. So let's go 19 divided by 2 equals. So 19 divided by 2. So I know that 2 times 9 is 18. So we go, well, it's 2 times 9. So it's 9. Remainder 1. And then when I look at this, I'm going to go over here. It's going to be 9. My remainder is 1. So it's my numerator. And my denominator always stays the same. It is 2. All right, hopefully that makes sense, guys. You might need to watch this one again. This is a tricky concept, but hopefully things like this video will help. All right, guys, remember, come see your teacher if you're unsure.